Okay, so this is lesson 13 with Brianna and Mitzi, and we're going to go ahead and get started. Do we want to go through maybe, let's see, any of the questions before we get started?
I'm okay. I mean, unless you have any big ones.
Yeah.
I think we can just go at the quiz and see how we do.
How we do? Sounds good to me. Sounds good. Let me pull it up. Let's see here. Okay. All right. I literally like jumped out of bed just now. Sorry.
It's okay. It's early there. I understand.
Yeah, usually I'm up early, but not today. Um, okay, I'll share my screen and let me pull up the quiz right now. Okay. All right. So, okay, so we need to have the T distribution app, output open, and then those two files. Let me pull it up. Dentist office bills and freshman dinner. Freshman dinner and dentist office bills. Okay, I'm going to close some of these other files that I forgot to close. Okay. All right. So, first question: what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark how they apply.
I think it's the first two. A simple random sample was drawn from each population, and then the mean is
The
normally
same.
distributed for each group. Yeah.
Okay. The same two then from the other requirements for the other things. Okay. The test statistics for a hypothesis test comparing two means with independent samples is a
I think it's a T-score because that's what we find on the Excel.
yeah,
I don't want to think too much into it.
because the T-score is what we usually get.
Yeah.
Yeah, sample is a T. It's the same thing. Okay. Samples are independent if knowing which subjects in group A determines which knowing which subjects will be in group 1 tells you nothing about subjects in group 2. That's the answer there.
Yeah, it's the second one.
Yeah. Okay, for the next 6 questions, get my sketch paper out. Or no, I guess. Okay. This data represents a sample random. I'm going to let you share your screen on this one so we can see, and so I can follow along with yours in doing this one. The data represents.
Well, I don't. If you're on the two sample t-test.
Yeah, I'm going to just pull my information out. Hold on, I didn't get done reading through the questions. Remember this. The mean, if the mean bill Idaho falls to less than the mean bill of Vicksburg, which means you'll have the null hypothesis. Okay, so we're going to have Idaho Falls. Let me see her. I'll make sure I get this right. So I'm going to copy this information. Hold on. This is Idaho Falls. Two-sample test. So I was trying to figure out which one goes first in the first column. Let me see what you got, Brianna.
It says somewhere on the, make sure that.
327. Okay. Okay, let me put mine in too.
Yeah, the Idaho Falls is in the first column, and then the Rexburg is in the second column.
Okay. Rexburg, gotcha. Ah, it won't let me paste it. Why would it let me paste it? Come on, don't be weird. Okay, hold on. There we go. And Idaho Falls is in the first one.
Mm-hmm.
Okay. All right. So our question is,
What's the degree of freedom?
which is 19. Oh no,
37.997. And I looked up on the lesson why, like how last chapter it was just one under.
Right.
And in the reading, it's like, you'll notice that this is not a whole number. This is called the Satterthwaite approximation for the degrees of freedom. Do not worry that this is not a whole number. Just record the value as it is given. So I'm like, okay, no more questions about that.
Values it's given is good. So that was 37.996.
Yeah.
The next question is, what
What
is the
is this
sample standard for Rexburg? And that one is
just be this.
sample standard deviation, yeah, 206.637. Oh, you're so smart copying and pasting it.
I don't want to mess up on the numbers. What is the test statistic? Negative 0.434.
Yeah, the T score.
Hopefully we're doing this right.
I know, it seems too easy, right?
I know it does seem really easy, but we've kind of just built upon
The last lesson.
So
And then the p-value. Okay.
333.
Yeah. Now what we're supposed to
This is where you come in handy. Do we reject it or fail to reject?
the p-values, wait, 0.667, right?
Oh, is it?
Am I looking at it wrong? Hold on, let me look at yours.
Well, is it less than right? Or is it?
Oh, shucks. Okay, yeah, you're right. Let me change my, yeah, your p-value is different. So less than, yep, now I have it right.
Okay.
So what was our level of significance again? Let me look up here. It's 0.1. So this one is greater than, so we fail to reject the null because the p is not low. Okay, suppose we used not
You had the
a not equal to, then we get a p-value that's 0.667.
Yeah.
Okay, and I have to really read this. We have sufficient evidence that the mean just bills are different. We fail to reject insufficient. Fail to reject the null. So let me go back to the question. The question, because this is where the sufficient, insufficient get kind of crazy. Perform a hypothesis to determine if the mean bill at Idaho Falls is less than the mean. So our null. So what we're saying is we have insufficient evidence, right? That Idaho Falls is less than, or let me look back at the question. We have,
So they're different.
yeah, because we have insufficient evidence that the mean dentist bills between the two cities are different.
Well, I mean, I don't know if you're like you on the Excel, you see the different means. So it's like I don't know. I've never been good at these questions.
I know, let me look at this. Hold on, let me look back and see if it's the same. Since p-value is greater than the level of significance, we fail to reject the null. So we, even though it may seem, if the p-value is correct in this, then we have to fail to reject the null because it's greater than 0.1. But because we're trying to prove that it is, trying to prove that there is a difference, we have to see there's insufficient evidence that the mean dentist bills between two cities are different.
Okay.
Yeah.
For the next questions we use.
I think these things all the way through, and then I get them wrong. Sorry. I'm gonna just do that. For the next 6 questions, use data. Okay, I got that. Data represents the times freshman students from Utah, Colorado, cook their own dinner. Okay, so U1 is going to be the Colorado people. Okay. Let me see.
The first one's going to be Colorado?
U1, right? The first means is...
Oh, yeah. Okay, that's weird. We actually have to switch them around this time.
Yeah.
Like, usually it's just copy and paste and it's fine. Huh. That's really weird.
Let's see. Because, let me see here. Oh, sorry. Okay, so the first means... So
the null hypothesis is that they're equal to each other?
So the null is that they're equal.
Oh, so the alternative is that they're not equal, right?
Now I'm trying to read through the question again for the next six question. This data you suspect a freshman from Utah cooked dinner for themselves a different number of times. So it's different than it's not equal to.
Okay.
Yeah.
What I thought. So
Level
then,
significance is 0.5. 5. Um,
the test statistic
wait
is
a minute. It says here the null hypothesis is HA equals. Why does it say HA instead of HU? I think that's a typo. It is the null.
oh yeah.
So it's different. 2. Okay. The point. Okay. What is the test statistics? Sorry. And you have
I
negative
maybe
0.845.
yep. What is the p-value? I mean 0.411. So we do have
0.41. Yeah. Yes, that's what I have in here. What decision did you make? So this is greater than, again, the so the p-value is high, so we fail to reject again.
um in the margin of error. So
Hold on. What was not equal to? Okay, I always forget to look at that. Okay, and then what was the question?
so the margin of error, we do what we watch that video for, right?
Oh yeah. Determine 95% confidence level. Estimate the difference between you. Input your answers below. Okay, let's see if we remember this. So we take the confidence interval minus the low minus the high, right? Or the high minus the low divided by 2.
Do we
I wrote
subtract
it
them or add them?
Let's see. Hold on a second. I wrote it down. Margin of error is lower confidence level minus the higher confidence divided by 2. So the lower would be negative. Wow, how do we do that? Because these are both negative numbers. I mean, it's going to turn into both negative numbers, right?
Yeah, I got negative 5.147 minus 2.214, which gets negative 7.362, which then makes negative 3.681.
Divided by 2, yeah. Oh, I wrote down the the formula when we watched the video.
Yeah.
So, okay, why do I feel like I'm still feeling like I'm still trying to wake up here? Okay, so you said that was that divided by 2 was negative 3.68, right?
Yeah.
0. Okay.
381 for 7 rounds up.
Let me see your answer on that. I must be wrong. 5, negative 5, 368. Oh, see, yes, you're right. That's what I have. Sorry, just I did it wrong. Negative 3.681.
I hope we're not doing this all totally wrong.
I know. Input the lower bound was negative
147 and then
5.147.
214. Well, I guess I should submit and see what we did wrong.
Negative. Oh, sorry. 2 point. Okay. Well, we can both submit it. Well,
I
that
can
way we.
do it. So if
Yeah. I'm not done writing my answers in. Hold on a second.
here, I'll just go for it. I'm scared.
Me too. Not as confident today.
Oh, 94%, 18 out of 19. So we missed the margin of error. That was the only one we missed.
What?
We did that one wrong. But I mean, I think that's really good.
Yeah.
But
Lower CF minus higher CF divided by 2.
I'm gonna watch
I
that
wonder
video
if it
again
was
real
supposed to
quick.
be the other way around. I wonder if it should have been 2.
Yeah.
But
Are
then
you still
again,
on the quiz?
yeah, but the thing
Okay.
is, we just did it right there where our lower CF was negative 5.147 minus
Here, just
2.214.
maybe try positive of that number, because if you do it the other way, like if you
Oh, I see what you're saying.
subtract it, like the higher from the lower, you get the same, but just positive.
I see what you're saying.
Or
So instead of a negative 5, no, stay with the negative 5, but instead of minus, add, so that it becomes negative 2.93 and 1.
well, hold on, I'm pulling up
47.
the video.
What was that?
I pulled up the video again.
Hello, everyone. I'm
to
coming
see.
to you because I've had a couple questions about some questions on the homework. And so I wanted to cover this with you so that way you're aware, if you get this on the exam later on, kind of what's going on here. So the question is, I believe, from homework quiz question 1. And this is a common problem and issue that students have to
Hold on. We've already know that part.
Here's the rate of return.
You know what? You're right. We got to add it because remember it's between the two.
And so I've pasted that right here.
To the positive because we want to find the area in between.
95.
Yeah.
Confidence.
Yes. Yeah. That's what we were supposed to do. Okay. I didn't finish my questions because completed individual. I did not. I actually purchased. I did. So.
Confidence intervals. So what we do is our confidence level is there, and what we're looking for here is the confidence interval. So we have both of those. If we look at those two values, these are the actual rate of return confidence intervals. So if we go back to here, these would be the values that were tied to the curve, and something asked for the margin of error. So I'm going to take both of these. I'm going to copy these out. I'm going to take out this here. I want to paste the values. There's my values. And now I can simply go through. I'm going to make this a little larger for you guys to see.
Oh, it's saying don't use Excel. That's where we.
This minus.
Oh, higher minus the lower. Divided by 2.
The larger number.
Higher minus 2. How did he do that? Can you go back a little bit?
Yeah. Well, he just grabbed them from
the higher.
Yeah.
Why did I put lower? Okay.
So
Higher.
where's Mike? So let me delete all
Minus lower.
equals this one minus that one equals that one divided by 2. So it's just what we put, but positive. 3.681.
So higher minus lower, so it becomes an add.
Yeah.
Okay. 5.14. So I'm gonna try to hand it out just to see if because it said something about Excel.
Yeah, that's where I did it.
4, 5, 6, 6.
I'm going to put in all my answers for the quiz again. I know it's only like 6%, but if we know how to do it, I might as well get 100 on it, right?
Yeah. No, I did the same. So that's 2, 1, 3 point 12, 6, 8. So you got 6.81 on that one?
The answer?
Yeah.
No. Mhm.
3 point.
So equal, I mean, 2.214 plus negative, I mean, plus 5.147 gives you 7.362.
Yeah.
And then you divide that.
Oh, I see. Because I got 7.361. It's 7, 1. And then your answer is
681.
Oh, yeah. This is a 3.681. Okay. So by hand, I got 3.680.
That's close.
Yeah.
I'm proud of us for getting the we have sufficient information, that one, right?
Yeah. So I got lower because I didn't do my homework beforehand.
Oh.
So
But is that one right?
I didn't go back and put it in yet. So we have the answer is 3.681, right?
Yeah.
So I've got to go back and put it. What does it say? The SPS.
I think I got it all back entered in correctly. Well, we'll try it with the positive margin of error. There we go. Yep, that's right.
So 3.681.
Yep.
Okay. Alrighty. Good
Perfect.
job.
Yeah, good job, you too.
I think we're kind of getting the concept. Well, I think I'm kind of getting the concept
Yeah.
here, just a little bit. All
Well,
right.
have a good
Thank
temple trip
you.
or whatever you're doing.
Thank you. Yes, I'm at a temple trip right now. Then I go to Utah for just a couple days and come back home. So hopefully next week Tuesday, I'll be back at home, back in my sink.
Okay. Well, I'll see you
Thank
then.
you. See you.
Bye.
Okay. Bye bye.